This is Going Over Calculus Homework, page 303, problems 33, 34, 35, 39, 44, 45, and 46. Okay, starting us off on this one, we need the antiderivative of sine. Well, remember, here's what we've got on the chapter 3 formula sheet. It says the derivative of cosine is negative sine. So we want the function that when you take its derivative, you get positive sine. So we're going to have negative cosine of x. And again, the reason is when you take the derivative of just cosine of x, you get negative sine of x. So negative sine of x times this negative will give you the positive sine of x. That's the antiderivative of sine of x. We put the straight evaluation bar, 0 to pi, and start evaluating. Top one in first, negative cosine of pi minus negative cosine of 0. Okay, pi is 180. We're looking at adjacent over hypotenuse. That's going to be a negative 1. Cosine of 0, that's going to be a positive 1. So here's what we got. Negative of negative 1 minus, and then we've got negative 1. There it is. Okay, so hey, minus a negative plus a positive, minus a negative plus a positive. We have 1 plus 1 is 2. There's our answer right there. We'll do a check. Let's do a check right here. The original equation, sine of x, 0 to pi. Here we go. First of all, check my mode. I need to be in radians. Yeah, I am in radians. That's good. Okay, let's go clear it out. Math. We've got number 9. It's going to be 0 to pi. There it is. And we have the function sine of x. Looking good. Let's go outside, put our x for the variable. There it is. That's the answer too. Okay, excellent. There we go. The next one, we've got 34. Here we go. Problem 34. Yeah, here we go. We want the antiderivative of 1. Well, that's going to be just x. The derivative of x is 1 plus, now, the antiderivative of cosine of x. What function, when you take its derivative, you just get cosine of x? From chapter 3, it is sine of x. There's the antiderivatives, plural. We put the straight evaluation bar, 0 to pi, and start evaluating. Here we go. We've got parenthesis. We've got pi plus sine of pi minus 0 plus sine of 0. Well, sine of pi, sine of 180, that's opposite over hypotenuse. That's nothing. That's 0. Sine of 0 is also 0. So all we have here is pi minus 0. It is pi, which of course is about 3.14. Okay, number 35. See what that has. Okay, here we go. Now, on this one, notice we have a constant out in front times the function. Let's bring that out in front of the integral. So here we go. Just rewrite it. Okay, 0 to pi over 3. Now we've got secant squared of theta d theta. Don't worry about the variable. Just think of it as x. Now, here's what we need. We have 2. I'm going to put little bracket. Now, what function, when you take its derivative, you get secant squared? Notice on the chapter 3 formula sheet. Let's do it up here. Chapter 3 formula sheet. Here's what I see. The derivative of tangent is secant squared. So there it is. The antiderivative of secant squared is tangent. So that's what we're going to have right here. It's going to have tangent of x. We're going to evaluate just the tangent from 0 to pi over 3. Now, notice what you see here. You see 2 times. So I'm going to go 2 parenthesis. Now I'm going to go tangent of the top one, pi over 3, minus tangent of the bottom one, 0. Okay, let's see if we got a little room. 2 times. Let's do that in our calculator here. Okay, we're in radians. Looking good. Okay, now let's go tangent of pi over 3. Good, then minus tangent of 0. Tangent of 0 should be 0. Okay. Our answer for that part is 1.73. 2 times 1.73 is 3.46. There's our answer. Again, you can check it by going back to the original and plugging it in your calculator. Okay, let's see what we've got. Okay, on 39 and 40. Okay, here's 39. Now, the best thing to do on this one, at this point, I'm going to multiply it out. So here's what I see from -1 to 1. Let's multiply r plus 1 times r plus 1. R times r, we get r squared. 1 r on the inside, 1 r on the outside. That's a total of 2 r's. And then the last term, 1 times 1 is 1. Now let's do the antiderivatives. We'll do it in a different color. Okay, the antiderivative of r squared. It's going to be r cubed, 1 power higher. 3 times what gives me the 1? 3 times what gives me 1? It's going to be 1/3. Now, plus, okay, this is r to the first. So our antiderivative is going to be r squared. 2 times what gives me 2? There's just a 1 right in front. I don't have to really write it. Plus, now, the antiderivative of 1. It's just going to be r. There we go. Again, you could do it all in x's. It doesn't really matter. Okay, straight evaluation bar, -1 to 1. Let's start plugging it in. Here we go. Parenthesis, 1/3. 1 cubed plus 1 squared plus 1 minus parenthesis 1/3 -1 cubed plus -1 squared plus -1. Okay, let's see what we've got. Move it up a little bit. We got room here. Okay, this is going to be 1/3. This is going to be 1 plus 1. That's 2. Parentheses minus. This is going to be -1/3. With the -1 to the third power is -1. Okay, now, -1 squared is 1. 1 and -1, they cancel each other out. Here we go. This is 2 and 1/3 minus a negative plus a positive plus 1/3. Hey, that's going to be 2 and 2/3 or 2.66 if you want to check it in your calculator. Here we go. Keep on moving. Yeah. Look at this problem. They said find the area between the curve and the x-axis. Well, and they even give us the x values here from x equals -2 to x equals 2. Well, we want an integral. That's all it is. That's really all they're asking you to do. So let's do the integral here, the antiderivative. We're going to have the antiderivative of x to the third. That's going to be x to the fourth. 4 times what gives you the 1 out here? It's going to be 1/4. There is a minus. I'll put a minus. Now, this is x to the first. So the antiderivative is going to be x squared. 2 times what gives you 4? Going to have to be a 2. There it is. Those are the antiderivatives, straight evaluation bar, -2 to 2. Let's go ahead and evaluate. Parenthesis, 1/4, 2 to the fourth, minus 2 squared, minus parenthesis 1/4 negative 2 to the fourth minus 2 negative 2 squared. Okay, so we've got 2 to the fourth is 16. 16 times 1/4 is 4. That's going to be 4 times 2, that's a minus 8. Minus, okay, here we've got negative 2 to the fourth. That's going to be a positive 16. Positive 16 times 1/4 is 4. That's going to be a negative 2 squared is 4. 4 times 2, that's going to be a minus 8. So here's what we got. Negative 4 minus a negative 4. Yep, there it is. Plus a positive. Our answer is 0 on that. Answer is 0 on that. Okay, now let's go look at the last two. Here's number 45. They said, find the area under the curve. Well, you could see we have really two areas, and they're broken right there. So the first area is under the curve of x squared from 0 to 1. The second area is under the curve 2 minus x from 1 to 2. Let's set up the integrals. Here we go. The first one I'll do in black. It's the integral of x squared from 0 to 1. Okay, the second one I'll do in green. Here we go. It's the integral from 1 to 2 of 2 minus x dx. Okay, let's solve each one of them separately. See what we got. Okay, antiderivative of x squared, that's going to be x to the third, and we're going to have a 1/3 in front. I'm going to put my straight evaluation bar 0 to 1. Now the second one here, antiderivative of 2 is going to be 2x. Antiderivative of x to the first is going to be x to the squared, and I'm going to have a 1/2. Let's test that. Derivative of 2x is 2. Derivative of negative 1/2 x squared. 2 times a negative 1/2 gives me a negative 1. 2 minus 1 is 1. That's it. I'm evaluating that one from 1 to 2. Okay, here we go. Plug in the 1. 1/3 1 cubed minus, plug in the 0, that's just 0. Plus, let's plug in the 2. 2 times 2 minus 1/2 times 2 squared minus 2 times 1 minus 1/2 times 1 squared. Okay, we've got 1/3 here. That's the area of the first one. Plus, let's see what we've got here. We've got 4 minus, that's going to be 4, that's going to be 2. That's going to be a 2, and that's going to be a 1/2. So we've got 1/3 plus, there's 2 minus 1.5. So here's what I got right now. Let's move it up. Yep. I've got 1/3 plus 2 minus 1.5 is going to be 1/2. If I want to put these together using fractions, I got to use a common denominator. Let's multiply by 2 over 2 here, 3 over 3 here. Here's our answer now. I have a common denominator. The common denominator is 6. I have 2 plus 3 is 5. There it is. 5, 6, or about 0.83. Okay, the last problem. Let's see what do we got here. Okay. In fact, we will save the last problem. It'll be on part 2.